collection in Java is the process by which Java automatically removes unused or unreachable object from heap memory. So you don't have to do it manually. Java manages memory automatically using Java virtual machine. So garbage collection primarily manages young generation and old generation. So how it works is it tracks the object through references. Like if an object is no longer reachable or a no live reference, it becomes eligible for garbage collection. So, a basic garbage collection algorithm involves two phases, mainly which traverse from root objects and mark all reachable or live objects, which is called as marking. Then, traversing memory and reclaiming memory from unmarked or dead objects. It's called sweeping phase. So there is another phase like optional phase, a compact phase which follow to eliminate memory fragmentation. It is used in many garbage collection implementations. It's simple but can have a stop the world passes and fragmentation issues. So JVM again uses a generational GC memory management strategy to optimize garbage collection based on observation that the most object die young. So Java objects are grouped into generations based on their age, and each generation is collected differently for better performance and efficiency. So generation GC divides memory into young generation, which contains Eden and survivor spaces, then old generation. Sometimes also like a permanent generation or meta space also involved. So this is a pictorial representation which contains a young generation with Eden and survivor space, that is S0 and S1, then old generation or old memory. So the cycle here is, um, once the object or new object are allocated in Eden space, that is young generation, it's a first allocation using bump the pointer. Then a minor GC and major GC happens. So object allocation, minor GC, and like the frequently used major GC. So when Eden fills up, a minor GC is triggered, and surviving objects are moved to survivor space, that is S0 or S1. And the object survive multiple minor GCs are promoted to their older generation, like old memory. And as I mentioned, the major GC or full GC happens less frequently, and it collects like old generation using mark sweep compact, like as I mentioned, the basic algorithm. So it can also cause a stop the world passes, and maybe it's a slower as well. So objects that live long enough in survivor spaces are promoted to the older generation, and yeah. So the common GC algorithm in JVM are serial GC, which can be used by all Java version. It's best for small application and which are single threaded. And we have parallel GC, again can be used in all Java version, default in many JDKs, and it can be used where like required high throughput and multi-core CPUs are available. Then we have CMS, concurrent mark sweep. So it is depreciated because it has low pass apps. And G1 GC garbage first algorithm. It's a default in Java 9 plus version, and it's a balanced performance and has a low passes. Again, we have J garbage collector, and like it's for Java 11. It's best for very large heaps and ultra low passes. So for all these algorithms, has like if you want to utilize these algorithms, there is a flag for each algorithms, like hyphen double x, like if you are using any application services like Tomcat and all, basically it will be available in catalina.sh. So you need to add these flags in the Java underscore ops parameter, like -xs. Like if you want to use serial GC, you can use plus serial GC, plus use serial GC, or use parallel GC and all. So the flag need to be added in the Catalina.sh or in the IDE as well. So all these things, like if you are not explicitly mention these GCs, um, the system will take a default algorithm. So we have memory tuning options as well. As I mentioned, the same thing wherever you uh, add these flags, or if you want to tune memory, you can use these options. We have xms, like set initial heap size. You can also set maximum heap size, and if you want to set a size for young generation, initial size and maximum size, you can use new size, max new size. Again, you can update the ratio of hidden to survivor spaces. And we have this already discussed, like initial meta size and max meta size can be also tuned. So when to tune JVM memory? Like frequent GC passes, like increase heap size or use better GCs. And when you come across like out of memory error, you can increase the heap size. You can set a maximum heap size. You can pile up those things. Again, you have out of memory error with a meta space, increase the max space size. And when you have a stack overflow, increase the stack size with -xss. That's the parameter for it. And the best practices for efficient memory management are minimize object creation, especially in loops. Use primitive types instead of wrappers when possible. Avoid memory leak via static references or listeners not deregistered. Use profiling tools like Visual VM, Eclipse Mat to monitor memory usage, and close the resources. Follow using finally block to close all the opened connections, like input output streams or database base connections. Then the memory leaks in Java, like although Java has GC, memory leaks can still occur. Long-lived reference to unused offset, static collections, returning object references, and not releasing resources, as I mentioned, for DB or file handling. Tools for monitoring and debugging are like we have JVM options, as I mentioned. We have profilers, and you can also go for logging GC activities. Yeah, this is all about garbage collection concept in Java. Thanks for watching.